The city, a vast repository of stories, each one branching out like the threads of complex code. They say every commit tells a story. So, what's my story? Failed developer turned cop? Couldn't write code, so decided to pick holes in others? Maybe it's me. Maybe I'm the issue in this reposa city. All I know is I'm the city's most trusted InvestiGITor. Lately, something's changed. Whispers say there's a new kingpin in town, pulling all the strings from the shadows. Goes by KB. Whoever it is, they are the kind of criminal that doesn't leave fingerprints on the keyboard, just a trail of cryptic commit messages and coerced histories. Anyway, this city is my home directory, and I'm here to clean up the code smells and corrupt blobs, no matter how many conflicts I have to resolve.
Welcome, ladies and gentlemen, to Crime Scene InvestiGITor, the case of the naughty commit. Welcome, cadets, to your very first day at Detective Academy. You've all just graduated from basic police training, and you think you're hotshots, but you're in my house now. Who am I? I'm your teacher for Detective Academy, Chief Inspector Detective Cadell, at your service. I am a principal platform engineer for Android at a company called Babel in Berlin. And when I'm not terminaling or bashing, I love and got really obsessed with Git, hence the job. Now, if you enjoy any of the nonsense you see here today in Detective Academy Day 1, feel free to check out my really stupid YouTube channel. Selfish plug. Now, because it's your first day at the Academy, we're going to put you through your paces. We have a jam-packed session. To start with, we're going to do a quick rundown on Git. Make sure we're all on the same page, but this is not a basic session. After we're all caught up, we're going to head to a mock fake crime scene where we're going to investigate a fake crime and go back in time and all that good stuff to catch a perpetrator on day 1. Exciting. Now, everything you see here today and much more will be captured in this Linktree address here. Feel free to scan the QR code if you'd like to look at any of the links that I point to, any of the videos, or any more articles diving deeper into the sessions. And please don't panic. You are more than welcome to take photographic evidence of anything you see at the crime scene, including my handsome self. But don't panic if you miss something because the slides themselves are in the Linktree. Now, I need to introduce you to somebody very, very special to me. It's my partner of many, many years, Detective Refi.
Hey, nice to meet you, folks.
Refi is an incredible sidekick. He is the Robin to my Batman.
Despite what this guy says, I'm the real brains of this duo. Somebody's got to keep Detective Cadell from walking into open manholes.
Refi, we decided we weren't going to talk about that in front of the cadets. Anyway, Refi is a marvelous sidekick and will always have our back, and we can trust him. Anyway, the final point to make is that the work of a detective, an investigator, is not about assigning blame to an individual. No. It's more about finding how, when, and why a problem occurred in your Git repository and having the necessary skills to properly solve that crime confidently and be the hero for your team. So, let's dive in. Spin move. Git is a version control system, meaning that it tracks changes to your repository over time. It stores these theoretical changes, these snapshots in time as these things called commits. You'll see these circular diagrams everywhere. Each one is a commit. Hooray! We all know this. Every commit has a unique ID, and actually this is generated from the commit's contents itself. You'll see that a little bit later. And it's a SHA-1 hash, meaning that it has lots and lots of characters. Hooray! So a commit has a unique ID. Not only that, every commit has a reference to its parent, or the commit that came directly before it. And you'll often see the diagrams with the arrows pointing backwards in time, and that's to signify that C knows about its parent B, but B doesn't know about the child C that it abandoned many years ago when it went out to buy a packet of cigarettes. Anyway, this creates something called a DAG, or a directed acyclical graph. Ooh. It's just a fancy way of basically saying you can pick any moment in time and through the lineage, find your way right back to the start of history. So every commit has an ID, and every commit has a reference to its parent commit. Hopefully it's somewhat obvious. Merge commits have 2 parent references, right? So we know about these things called commits. This is one of Git's objects. But there's 2 other types of objects that Git uses to recreate your folder structure at any moment in time. We know about commits, but the other 2 are trees and blobs. And they're really easy to understand. A commit you can think of as the container of change, the punch in time, the snapshot moment, and it contains all the information beneath it. Every commit contains a reference to exactly one tree object. And a tree object you can just think of as a printout of a folder, like you've LS'd a directory. And it will say, oh, there's these files and folders. So within a tree object, you also have other tree objects, aka subdirectories, and blob objects. You can think of those as the actual contents of files, right? So with these weird 3 objects, Git is able to recreate your project, your folder at any moment in time. Cool. That's very theoretical, Detective Cadell. Yeah, you're right. Let's bring it back to reality. How are these things stored? Where are they? Well, these objects, each of them are stored in a file. They're just files within the .git objects directory. The .git folder can be found in every single one of your Git repositories. Every single one. Cool, exciting. So all of these things, all of these objects are stored side by side happily in this .git objects directory. Cool. Let's just take a sidestep and understand how Git takes your code and turns it into one of these objects. Let's take a blob object, for example. When I use the git add command, for example here, Git will take my plain text code and it will hash it. It'll create this 40-character long SHA-1 hash that we'll just put off to one side for now. Then it will take the contents of the plain text file and compress it in zlib, making it more efficient, smaller to store on disk. Finally, Git goes to the .git objects folder. It takes the first 2 characters of the SHA-1 hash that was generated and creates a folder with that as the name if it doesn't already exist. Weird. Then, even weirder, it takes the compressed content and the remaining 38 characters of the SHA-1 hash and creates a file with that as the name. And that is how Git creates a blob object. Now, Detective Cadell, why on earth is Git doing this weird 2-character folder nonsense? Well, I'm glad you asked. This is one of many Git efficiencies and why Git is so bloody wonderful. Because imagine a world where, oh, the screen just died. Come back, screen. Yeah. Okay, that doesn't work. Imagine a world where the objects that are stored in the objects folder. Are you okay? All good? Yeah? Just got to wiggle the mouse. Okay. I'll keep wiggling. Thank you. Imagine a world where inside of the objects folder, all of the objects are stored line by line in one big folder. Now, whenever time Git does something Gitty, like walking the tree, it would have to index through maybe hundreds, maybe thousands, maybe millions of object files just to do its operation. That's bad. But with this, it only has to index through a maximum of 256 subdirectories, because of hex, and then some amount of files beneath that. So it's an efficiency. Hooray! Now, we know that these files exist. These objects exist as files. So how can we, as InvestiGITors, interrogate them? Well, let's just cat out the file and see what it says inside of it. No. Remember, it's compressed gobbledygook nonsense. We can't do anything with that. But we, as detectives, need tools to be able to work with these objects properly, and we look to Git itself for the answers. The Git command line gives us a huge range of tools to properly investigate these objects and all other manner of things. Now, just very quickly out of interest, who uses Git from the terminal or the command line? Raise your hand. Raise your hand. Okay, good. Okay, good. Those of you who raised your hand, bravo. Those of you who didn't, please stay today after class. Okay. Now, the reason that we're covering the tools, these commands that we're going to learn about from the command line is because, one, it was how it was intended to be used, and two, because when you go back to your work and you go back to your disgusting GUIs, your sours, your source trees, whatever they're called, and you click that button, you'll understand deeply the context behind what's happening when you click that button. Nice. Does anybody know roughly how many Git commands there are as of writing? Just yell out numbers at me. Numbers. How many Git commands exist? 250? Somewhere in the middle? 120? Somebody at the back just yelled 149. Well done, sir, at the top row. 149 is exactly right. You can split them into two categories. Porcelain commands, which you can think of as the friendly, nice, user-facing commands that we use every day to interact with Git, like add, commit, branch, etc. And then there's the plumbing commands. These are the scary, back-end, dangerous commands that Git itself uses to do its gitting and are really useful for when you're writing your own Git scripts. Yeah. So we know that there's these Git objects, we know there's files, and we know we have some sort of tools in the command line to work with them. Let's start looking at the tools. First of all, let's list all of the objects out. We can use revlist with these flags to list every single object in our repository. Boring, easy. It also says if they're a blob file, it also has the file name after it. You're probably saying, Detective Cadell, you silly Billy. You've put readme.md twice. I say, no. I did that on purpose to remind you that Git stores changes over time. So that first readme blob might just be how the file started. And the next readme blob might be how it changed. It changes over time. Cool. All right, so we can list the objects. Let's read them. Remember, we can't cat the files, but we can use git cat file to do the exact same thing, to basically give us the contents in a readable way. There's two main modes of operation. -t for type. So we would pass cat file -t a hash, and it would say, yes, that's a commit hash, or that's a tree, or that's a blob. Snore. Rubbish. The better way is with -p. For pretty print. And it basically does what we wanted originally. Gives me that hash, that object, in readable format. So if we give cat file -p a commit, we'd get this. This looks familiar. There's a commit message and an author. And importantly, a reference to the parent commit. Remember I said that earlier? So there's the reference to the parent commit, creating that DAG. And even more importantly, as I promised, a singular reference to a tree object. Well, let's take that hash and stick it into the exact same command. And we get this output. It's as though I've just hit ls in that directory, right? I'm seeing files and folders, or blobs and trees. So let's take one of the blob objects, and put it into the exact same command, and we get, finally, our file's content, the plain text that we originally saved. Cool. Now, if any of that sounds interesting and you want to learn more, unfortunately, I don't have time to dig into the .git folder deeper, but a very handsome cave explorer about 2 years ago took a group of enthusiastic cavers into the .git folder cave thing, and they recorded their findings. You can find the video, usually this is easier because I'm talking to DroidCon crowds, but it's a website called DroidCon where there's videos, and the YouTube channel for one of the other Android maker thingies called Inside the .git folder. Anyway, let's move on.
Detectives, there's been a horrific crime.
There's been a horrific crime. Spin move. There it is. Oh, it's okay, students. We're at the crime scene, and I know I promised you a fake mock crime scene, but I guess there's nothing better on day one than a real, brutal, bloody crime. Some monster has, well, you'll see it. Go through the police rope, and I'll see you on the other side. Brace yourselves. It's broken unit tests! That's the crime! Oh, God! Oh, no!
Who would do something so barbaric?
Oh, Refi, I have no idea. Only a monster, a demon, could do something like that and leave those poor unit tests bloodied and destroyed in the streets. But I know one thing, Refi. With the power that Git gives us, we will catch this criminal and bring them to justice. Okay, Refi. In order to find this criminal and when the crime happened, we need to go back in time. We need to travel back to when the crime happened.
Hey, dreamer, come back to reality. It's not like we've got access to a time machine.
Refi, you've been doing this job long enough. You know we do. And it's called Git. Because remember, Git stores changes over time, meaning we can go back to any moment in the repo's history and see how it was. And there's 3 types of time traveling I want to tell you about. First of all, there is the just visiting variety, where you jump back in time, have a little look, and when you're ready, return to the present. There's the do and undo. Ha! It's rewind time. That's my Will Smith impression. Thank you. I'll see you tomorrow. Yes, that was an awful impression. I shouldn't do that anymore. Do and undo. It's where you move forward in time, but you take some change from the past and flip it, invert it. And there's finally danger mode, which is my favorite, moving back in time, but a little bit more permanently. We're going to look at each of these three modes with a description and then a visualization, because I'm a visual learner, and the visuals help me understand better. So, number one, just visiting. This uses the git checkout command. Usually we use that for switching branches, but you can actually do git checkout and any git ref. And a ref is a reference, is basically like a nickname for a commit. So we can pass any git ref, like a commit hash, like a branch name, like a relative ref, head, where I am now, or head -1, one before now, and git will jump to it. So let's go to the visual. Here's a very simplified commit history, very, very simplified. You'll see the commits there. You'll see head, where I'm pointing at right now, what I'm looking at. If I'm at the tip of a branch, you'll see the branch name above it, in this case, main. And because I'm a giving person, I wanted to put actual file contents in the bottom of the screen. So these two boxes in the bottom right are actual files that exist in the .git folder, so you can sort of connect the dots. For example, we've got the head file in the bottom right there that contains the text ref's head main, which is just another file in the .git folder, which is containing the commit hash for E, the actual commit hash. And that's how Git knows where we are. Anyway, off topic. So let's jump back in time. Let's have a look. I'm going to jump back to C. So I'll do git checkout and the commit hash for C. My head will jump me back to C. I'll see the world from the past, how C was. Ooh, something interesting's happened. I'm not in a branch anymore. In fact, I'm in something called a detached head state, which is a really terrifying, weird way of saying that we're not at the tip of a branch anymore. It's not scary, really. Anyway, when we're ready, having looked at the past, we do git checkout, the branch name, and we'll jump back to E, the present. Easy. Do and undo. This uses the git revert command, and it basically moves you forward in time. You specify a commit using a ref again, and it will flip that commit. Let's see the visuals. So here we are again. I'm going to use git revert and the commit hash for just the commit I'm on at the moment, E. What will happen is I'll move forward in time, creating a brand new commit, but I didn't change any code. And F is just the mirror opposite of E. So whatever E's diffs were, if E's diffs were minus startup, add cleanup, then F's are the opposite, add startup, minus cleanup. So you can just revert, you can undo things, easy. And finally, danger mode. This is brilliant. This uses the reset command, which is a little bit scary for some people, but hopefully will demystify it. It moves you back in time like checkout did, but also updates your references. We'll talk about that in a second. Git reset has 3 modes of operation, soft, mixed, and hard. And these modes of operation just tell Git what you want to do with the changes that you're now eviscerating from time, that you're skipping back past. I'm going to show you a visual now, make it a little easier. So here we are again. I'm going to use git reset soft mode and C. So jump me back to C. Something interesting's happened. I'm still at the tip of main branch because main itself has been updated. See what I mean by a little bit more permanently? And soft mode, you can see commit D and E. The changes have been taken from D and E and put into the staging area, as though we've typed the code, saved the code, and used git add to tell Git about those changes. Cool. So mixed, which is the default operation, is the same thing. We move back, head moves, the branch updates, and the changes from D and E are put lovingly into the working directory, as though we've typed the changes and saved them, but have yet to tell Git about them. And finally, you've probably guessed the last bit. Hard is the exact same thing, moving back in time, update the refs, but the changes from D and E are taken and lovingly drop-kicked out of existence. Wiggling the mouse. Drop-kick out of existence. I did. Somebody said, have you turned sleep mode off? And I was like, yeah. But I didn't. I lied. Here it comes. It's coming back. 1 second, because the visuals are important. There we go. OK. Going to keep wiggling. Right, so hard is drop kick out of existence. Cool. And that's why people say that this is the... OK. We'll do a little intermission down. Oh, there it is. OK, I was going to get weird with it. Cool. So, and this is why people say that this one is the kind of scary, dangerous one. But it really isn't. When you understand the crux of this talk, the most important idea is the idea of unreachable commits. Now, what we just had, D&E looked like they were lost forever, but they're actually just unreachable commits. They're still there. They just can't be accessed through the usual branch and tagging system. They're sort of just floaters. But they're still there for now, asterisks, okay? They are still on your machine, meaning we can get those changes back again. So this is a better visualization of what just happened. D&E are sort of off of the main branch. So all we need to do is git checkout and the commit hash for E. And we're there. We see E again. We see the changes. Again, we're in a detached head state. That's hard to say a lot. Detached head state. But all we need to do now is create a branch from where we are. So I create a branch, and easy peasy. The changes are back, no more worries. But Detective Cadell, for you, that was very easy. In your example, you had single-letter commit hashes. For us, hang 10. The old N64 reboot. Here we go. Don't be scared, screen. Let's get a little applause for the screen, can we? A little applause. Cheer it on. Let's go, screen. You got this, screen. You go, boo. All right, hang 10. Have we got any IT technicians in the house? Any developers? There we go. Thank you. Somebody A. If it goes again, go ooh. And if it is, because I can't see it. For you, Detective Cadell, that was very easy. A single commit letter hash in your example. But what about when we have hashes that are 40 characters long? How are we supposed to figure that out? Well, I'm glad you asked again. I'd like to introduce you to one of the greatest commands that you'll ever use in Git for saving your own ass, and that's reflog. As you're moving around Git is keeping an update every time your references are getting updated. So when branch tips change, when your relative ref head changes, Git's keeping track of that. And the reflog command just dumps that information back out to you with the newest entry first. So in our example, where we did the hard reset, we're like, that'll be the first entry of that file. So we look at the line beneath it, and there is the commit hash in the first left column that we can check out and get our code back. Nice. But wait, there's one more thing. I said that they're still there. Those unreachable commits, they're still there, asterisks, for now, until something happens. And that's until possibly Git uses its garbage collection system, its very sophisticated garbage collector, which you can manually trigger using the git gc command, but it automatically runs on a bunch of Git moments. Its main objective is to take the current way we've been storing our objects in the .git objects folder. It's called loose because they're just jingling around in there in 2-character folders, and deleting them, turning that information into something called a pack file. And a pack file is where Git flipping wins the version control wars, but we don't have time to talk about that. But luckily, those cave explorers I mentioned earlier, videos and such in the link tree, they went deep into pack files and why they're so powerful. But for us, we're looking at the garbage collector because it could also, maybe, possibly, clean up unreachable commits. Maybe, possibly. We'll cover that later. Refi, we have a little problem. We've just been jumping back randomly in time, trying to find when the crime happened, but we're just guessing. We need a better way.
Man, this search is gonna take a lifetime. Yeah. It's like looking for a needle in a haystack.
Yeah, exactly, Refi, because we're just randomly guessing when to go back to, when to go back to. We need a tool to help us figure out when to go back to. And luckily, we have just the tool, and it's the incredible git bisect command. Now, if you don't know about bisect, then I'm so glad I get to tell you about this. Bisect meaning to cut or divide into 2 equal parts. It essentially performs a binary search on your Git history for whatever it is you're looking for, whatever it is. In our case, we're looking for when the unit tests were first brutally murdered on the streets. So let's see how that would look. Again, here's my basic commit history. I would start the bisect process with git bisect start to say to Git, hey, yo, shit's about to get crazy. We're going to do a lot of jump in, weird information. Hang with me. Now that Git knows things are about to get crazy, we tell it 2 pieces of information. Git bisect good, and a commit reference, and git bisect bad and a commit reference. The good reference is the latest, I always forget this, the latest time that we know for sure the tests were still working, and the bad reference is the earliest time we know for sure the tests were not working. And with that, Git now has a smaller range to work with, and it immediately springs into action. It automatically checks out the center commit in that range, and then just sits there looking at you funny. Because you now need to tell Git some information. You need to find out if this commit we're on is good or bad. So in our case, we would run the tests. So we run the tests, and the tests test pass. So we say git bisect good, yay. And Git immediately springs into action again. It eliminates that commit and everything to the left of it, and it takes the remaining range and jumps into the center. And we do this process over and over again. Run the tests. This time they fail, git bisect bad. Git can't eliminate this commit, but it can at least eliminate everything to the right of that commit. It takes the remaining range, checks it out automatically, we run the test, blah, 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 blah. You get the picture, bisect good. After just a few jumps and a few runnings of the tests, Git is immediately able to say, hey, F is the first bad, naughty commit. We got them dead to rights. We finish up with git bisect reset to say, hey, Git, calm down. We're done now. You chill out, take me back to the tip of the branch. And we've got it, Refi. We found when the unit tests were murdered. We found our naughty commit, B99. And look at this commit message. Made some good changes. Ja, klar. Crazy. Thank you. A couple of Germans in the audience. Appreciate that. So we got them, Refi. And the best thing about Git is it tracks everything. So we can see, using the git show command and our B99 ref, first of all, the diffs. Oh, God. I'm sorry. I didn't mean to put that on the screen again. That's brutal. Sorry that you have to see that again. OK, well, you're proper detectives. It's gross. It's disgusting. That's the moment the unit tests were killed. And even better, every commit has an author. So let's have a look at the author, and it's mystery user. Great. They have obfuscated their identity.
Curses. I thought we were hot on their tail. It looks like the perp's gonna get away with this.
Well, hang on a second, Refi. I found something here. Look at this. There's a file in B99 when the unit tests were murdered, and this commit called secret that wasn't in the repository in the present. They've left us a clue. Half a spin move. Now, cadets, it's very important to remember that you've started the academy. It's tradition in the academy on your first day to take a cadet class photo. So we're going to do that now. If you don't want to be in it, just hide your face or something. And we're going to take a cadet class photo so that we can put your picture on the halls of fame with the other cadets that went to Cadet Academy. Okay, so hang on a second. We're going to do an awkward selfie. Ready yourselves? I always make it blurry, so I'm going to stay real still. Smile, smile. Say git. Git. Thank you, 3 of you. Thank you so much. All right, come on now, calm down. There's been a crime, all right? Focus up. Back to academy. Spin move. Shit. Okay, Refi, this is very exciting. In the present, in G, we have no secret TXT file, but when we check out B99, there's this file here, meaning that the perp tried to destroy evidence. Let's have a look at what the secret file contains. Let's cat it out and let's see. It's gobbledygook nonsense again. All right, send it off to the techies and we'll continue our investigation.
Hey, partner?
Yeah?
Out of pure curiosity.
Come on.
Hey, partner?
Yeah?
Out of pure curiosity and educational purposes, if the perp had been smarter, how would they have properly disposed of those secrets?
That's an interesting question, Refi. But it's a good idea, because to catch a criminal, sometimes we have to think like a criminal. So yes, let's understand how a criminal would have properly destroyed that evidence, and maybe it'll bring us to another clue. The problem that we have that is in B99 or some other commit, there's this secret file containing our secrets. And in commit F or some other commit in the future, the file itself was deleted and those changes were committed to Git. But as we've learned over and over again, Git stores changes over time, meaning we can go back to any moment, meaning we can go back to B99 and see the secret blob. Not great. So those files, that information is still there. And even worse, just on the developer, just on the criminal's machine is one thing. But the moment that they push their changes to the cloud, other criminals, other developers will have a copy of that secret blob, and the problem propagates. So what we need to do is essentially go through history and rewrite it. We need to go through every commit, see if the secret's there. If it is there, delete and overwrite that commit with no secrets in it. Lovely. That sounds complicated. But luckily, we have just the command for the job. And it's the terrifying git filter branch command. Good. Thank you. In the man page alone, when you open the man page for it, it warns you, there's a warning of plethora of mangled histories and terrifying outcomes, right? It's scary. And in the wrong hands, this command is dangerous, but we, as professionals, need to understand it deeply so it doesn't scare us anymore. And we can use it to our advantage. So, up front, I will say, if you want a very boring, easy life of secret removal, then try these other repositories. In fact, Git itself recommends Git filter repo for secret removal, but we're going crazy mode, okay? We're going crazy. Let's dive in. So filter branch, as its main argument, it takes a rev list, or just a range of history. And by default, that's the branch you're on, aka filter branch. That's why it's called that. It will do some history-altering action on every commit in that rev list, leaving alone all of the branches and all of the rev lists, right? Cool. So hang on a second, Detective Cadell. We talked about unreachable commits earlier. Maybe you've seen those blue commits just get destroyed, but maybe you're thinking, are they still there? In which case, gold star for you, because yes, they are sort of, for now, still there. Let's investigate that. We could use the git show ref command, which is an awesome command. It shows you all of the human-readable refs, your branch names, your tags, etc., and the commits that they point to. And here we see something interesting in this output. An original subrefs. I didn't create that. That wasn't me. That was filter branch. It automatically backed up the changes I just destroyed because although it's a terrifying, evil command, it's just trying to be a good guy. One Rick and Morty fan in the audience. I heard it somewhere. Watch Rick and Morty. Anyway, so filter branch, trying to be a good guy. What about the garbage collector? We talked about that earlier. If we ran the garbage collector now, those blue commits are protected by that original refs because they're not unreachable technically. They've still got that pointer to them. And we can even use that reference to check out those changes again, and thus the changes come back. All up until we do something that deletes that protective wrapper, that reference. And now, if we were to run the garbage collector, those blue commits would be properly eviscerated from our history. Cool. So back to filter branch. The other side is the filters. And this is a really weird one. It's basically just the scope of change that you want to affect from history. I'm going to explain that better because it's weird. There's loads and loads of filters. You can look at them yourselves, but we're going to cover two. Message filter, because it's the easy one and will help us understand this command, and then index filter, because it's the useful one. So, message filter. This affects, and you'll understand now a bit better, the message filter is only going to affect the commit messages. In my history, it's only going to affect commit messages, right? So whatever will happen, every commit that it's rewriting history for, all that will be changed is the commit message. Cool. A standard input, it takes the original commit message, and a standard output, whatever it spits out, will be the new message. Let's look at some examples. We could use message filter, and then the command after it in the quotes is what we're doing to manipulate the commit message. So here you might just standard output glory to super earth, and it would make all the commits look like this. I'm not entirely sure why you do that, but probably because you're a good democratic patriot. Hold it. Okay, good, unseen, thank you. Helldivers kind of lost its touch a little bit now. Anyway, moving on, getting distracted. Alternatively, you could do something slightly more useful. You could manipulate the standard input to change it, to tweak it. And in this case, I've taken the original message and just wrapped it with some hyphens. Again, not sure why, but examples. Or you could maybe base 64 encode the original message, and you get output that looks something like this. Kind of looks familiar to me. Oh, anyway. So let's go back. Before we ran the message filter branch command, we had this list of commits. We'll just focus on one, nothing to see here. Once we've run the command, we have both our original commit and our new commit. But what's important is to know that the authors of those commits have stayed the same. We don't want to affect any other scope of history than the message. And what's even more important is both of those commits point to the exact same tree object because we've changed nothing else again. Cool. Now, let's go back to the important one, index filter. This will affect the index of the commit, which basically means the files that Git knows about in that moment. And you can always query that information with the ls files plumbing command. So let's look at some examples. We could do index filter, and then the command after it is what it's going to do. We could git add some other file on my machine, and that would make it as though the file had always been there, silly. You just weren't paying good enough attention. Or, more importantly, we could do maybe git rm file to remove the file from the index, and that would make it as though the file wasn't there, you didn't see anything. And hopefully you're thinking, well, that sounds like secret removal, because you'd be right. Here is a terrifyingly long single-line command that has to be broken up into multiple lines because of presentations, that is copy and pastable for secret removal. We're going to explain each and every chunk here. First of all, this filter branch command is using 2 filters. You can use 1 or more filters, right? It's using the index filter and another one we'll talk about in a second. Each filter directly after it has the command that it's going to do to manipulate that area of history. So for the first one, index filter, we've seen git rm. Ignore unmatched flag is awesome, because if you run git rm on a file that doesn't exist, Git will go, I don't know what to do, complain. But with ignore unmatched, it'll just be like, it's not there, carry on. Because maybe the secret file wasn't always there throughout history. Maybe it only came later. And the other one is tag name filter. This updates the scope of area, the tag names. Literally, the tag names is the tag like version 1 that points to a commit. And all it's doing is taking the standard input and piping it right back out. Nothing's being changed. And the reason that this is happening is so that Git can update where the tag is pointing to, because maybe the commit that it was pointing to isn't the right one anymore. So it's changing where the tag is pointing to. Easy. There's some great options on the filter branch command. Prune empty is great, because if the original commit that was added only added the secrets file, and now the secrets file is gone, it's an empty commit. We don't need empty commits, just delete it from our history. Psh. Force is amazing because it again shows us that filter branch is trying to protect us from ourselves. Without this flag, if filter branch runs and it sees that there's original refs, it'll be like, no, you've got original refs, bro. I'm not taking any part in this. But with the force flag, we go, yo, I'm crazy. Run that command. I know what I'm doing. Cool. Dash dash is a Unixy thing to basically say that's the end of your sort of options, and you're about to get your all-important main argument. And our main argument is this dash dash all, which is a rev list, literally meaning all branch, all tags on our machine. With that command, you will remove the secret completely from your machine. Once you run that command, if you're like, I'm not sure if I was meant to run it, it's a bit scary. First of all, don't panic, because you have time still. Like, genuinely, the command will start, but it won't do anything for like the first 5 or 6 seconds. It'll just say, hey, yo, if you didn't mean to run this, hit Control-C. And look, also, it points back to that other repo for secret removal. See, even Git's like, no, good luck with this. Anyway, if the command runs and the time elapses and it's starting to run, then again, don't panic, because remember, the filter branch has backed up our original changes. We can get them back relatively easily. The last piece of this puzzle, unfortunately, is those other criminals, those other developers in the world that have our secret blob as well. And unfortunately, there's no easy answer for this. The only thing you can do is force push. You should never force push, but in this case, you have to force push. You should never force push. And you need to use the dash dash all flag to say, force push everything. I'm the owner of history now. We're changing it all. And the only advice I can give you here is to do this physical process with your team, on a call, in person. Let them watch you hit the enter key as you do it. Let them see the fallout and what's changed so they know what's going to happen.
Detectives! It was base 64 encoded.
Base 64, Reffy, of course it was. I knew I recognized that format. We can decode base 64. All right, let's decode it and see what it says. It was me. Reffy, it's a confession. We've got him dead to rights, Reffy. It was me, your partner. Reffy?
I'm sorry, partner. It was either me or you. I didn't have a choice.
He said
sorry,
it, oh, there we go.
It was either me or you. I didn't have a choice. He told me he'd
revert my child commits if I didn't yada yada yada.
revert my child commits if I didn't do what he said.
Oh, Reffy, how could you do this to me, partner? We've known each other for years. You should have spoke to me.
All I know is he goes by K.E.D. He looked just like you, but with a mustache.
Reffy, I'm not gonna make it, buddy. You gotta help me. Please, Reffy. Please.
I gotta go. I'm sorry.
Reffy. hot laptop. Yeah, sorry about those audio glitches. Anyway, thank you very much for witnessing my ridiculous talk. Again, if you want to see anything that I've talked about or much, much more, articles, videos in the link tree up in the top left, socials in the bottom left if you want to follow me. And I'm one of those assholes that has my very own like branding and shit. So if anybody wants some stickers, there's Ben Cadell stickers, there's Ken Bedell stickers, which you won't really recognize and understand. The DroidCon lot get that. There's a whole canon. Anyway, it doesn't matter. There's limited edition Refi stickers from this year, and there's Ben Cadell pins in case you like my ugly face all over your shit. Thank you again for coming to my talk, and have a great rest of Civo, right? Yeah.
Amazing. Thanks, Ben. Let's give a big round of applause to Ben. I've never put that much effort in a presentation. That's so good. I have a question for you. What's your favorite Git command? You can only pick one.
Oof. Oh my God, that's really hard. Reset hard, because I use it all the time. Yeah. Just
right.
crazy.
I think we have time for some questions. So, anyone?
Only easy questions allowed. No, I'm kidding.
Would the good questions get like a Ben's sticker?
Yeah, sure.
Okay.
You can have stickers regardless.
All right.
Or pin.
What's your favorite collection
Like-
of commands?
Oh, I see. So the questions was, what's my favorite collection of commands? So I'm not sure if you're talking about like porcelain or plumbing, but I do a lot of scripting for Git so that I can like do a bit more with just, certain plumbing commands and stuff. So I do really like the plumbing commands, and especially the ones that give me information out. So like revlist, where I list the objects, I do a lot of diving into history. So I'll like put revlist into FZF, which is a really nice fuzzy finder for the terminal, and I'll take the output of that, which is a commit string, and put that into like git show or something like that, or like, yeah, just sort of that whole flow, if that makes sense.
But the collection exactly for deploying something to production.
Commits to, oh, right, okay, I see.
That collection.
So I think the question is, what sort of collection of commands would I use to deploy something to production, maybe?
Yes.
Okay, so in Babel, we use, it's very boring in Babel, so I won't talk about Babel, but we make our own like versions. We don't tag, anyway, boring. But in my side projects and all my other shit that I work on, I do tagging, so I'll merge back to main. I still won't release it. I'll git tag and git push the tag to the server, and then I'll use something like GitHub Actions to watch for tag pushes and do deployments like that, if that's what you mean, I think.
Yes. So for example, in my project, when we want to push some changes to production, then we also do some kind of reset, but not hard, just soft.
I don't get it, sorry. What were you saying?
I meant that the collection that I'm using in the project is always with git command, amend, but we are always doing a reset softly, not hard.
Yeah.
That's your favorite one.
Yes.
Should we use hard?
No. I mean, like, only use it if you need to. What's really nice is if you've ever like just done a commit, right, and you've done some amount of changes, and you're like, I kind of need to undo something from that previous commit, you could git reset mixed or git reset soft to take those changes and dump them back in front of you, changey, and then remerge, recommit after that, if that makes sense.
That makes lots of sense. Thank you very much. It was a great presentation.
Thank you for coming to my silly talk.
Cool.
Anyone else hot? No?
Right.
This guy's hot. Not in that way, sir. Thank you.
Thanks for the great talk. And could you not hate someone who does rebase force and force push on its own branch to update his changes on top of the branch?
So there's the constant topic of rebase and merging, right? Like I'm a merger. I like mergers and messy histories and just filtering out the merge commits. Rebasing, like as I'm sure you know and you all know, rebase locally, A-OK, right? And then if you're sort of going to a branch and it's just you working on that branch, force push, not. Anyway, we're not going to that, but yeah, I forgot the question. I started rambling. I'm sorry.
Could you not hate somebody who does that?
Could I date somebody who does that?
Not hate somebody who does it.
Not hate.
Yeah.
Well, hate's a strong word, sir. Hate's a very strong word, but yes, I would fucking hate them.
Okay.
Pardon my French. This is a 18 only.
Anyone else? Third question? Oh.
Okay, this one is maybe a far one, but do you know any good tooling for doing stacked PRs, like a stacked workflow, stacked Git workflow?
Stack.
Yeah, stacked Git workflow, essentially a PR on top of a PR. So if you're working on a big project,
Oh, I
it's
see.
splitting out the changes so that it's easier to review over time.
Yeah, I mean, not in terms of tooling, not really. Like, I just stick with Git and make a base, like a PR for the first change, and everything else PR-wise points back to that PR. And if you're using GitHub, the moment that that original base PR is merged in, the pointers from those other PRs will point back to develop. So you're not like losing the sort of, if that makes sense. I'm rambling, but I'm not even sure if that's what you're after there. I've just sort of.
I think so.
Okay. Bless you, sir. Very good.
Anyone else? What's your favorite version control system? Oh, sorry. What's your favorite
Mercurial.
What's your favorite hosting system? So like GitHub or GitLab or
Ooh, yeah. I'm a GitHub
GitHub.
purist. Yeah, open source. Yay.
Cool.
That sort of stuff.
Anyone else before we wrap it up? All right. Thank you, Ben. Really appreciate it.